Welcome to the code walkthrough for assignment 1A. Before we do this walkthrough, I'll first give you an overview of the course website, which can be accessed at the URL at the top left-hand portion of the screen. This website describes where the class will be held and when the class will be held, which you probably already know. It'll also provide the time when the final exam will be given, which will be in the same room as the classroom. I also outline the philosophy that drives the course, as well as summarize the prerequisites. In other words, what you should know before you take this course, as well as underscoring the fact that in this class, the Vanderbilt University Honor Code governs all the work. And what that means is that the tests, papers, homework assignments, quizzes, and so on, all must be done by you and you alone, rather than working in groups or teams. The course material comes next. First, we have the course logistics, which are various pieces of information that you should understand in order to do well in this class, such as when and where the office hours will be held, what the course will cover, what you'll be expected to do in the course, how the programming assignments will be handled. Make sure you read this link carefully because it's important to follow these instructions. And there's also a summary of the textbooks and recommended reading. Then we also have a big section that's currently mostly unfilled in. This is where I'll be putting, for each class during each week, the links to the MP4 screencast of the lecture, as well as the PDF versions of the slides that I present in the class. You can also access the video information from my YouTube playlist. And finally, at the bottom of the page, we have a link to the location where the programming assignments will be given. So if we click on that, you can see we go over here and we find ourselves at my GitHub repository in the CS891 subrepository. And currently this has assignment 1A, which is what we'll be covering here in just a moment. If you want to get access to this code and the projects, you simply go to the CS891 folder in my repository, and you go ahead and click on the clone or download link, and that will give you a Git URL. So you copy that. Once you've copied that Git URL, then you can simply go ahead and come down and use a shell like Bash or the Microsoft Windows shell or whatnot, and you can go ahead and clone that Git URL. So you go ahead and clone it, and that will then copy all the information into your local machine. It'll download it to your local machine. Once you've cloned the Git repository, you can take a look at its contents in a file explorer. If we take a look here, we have assignment 1A. If we click on that and go down inside of it, we'll see that there's all the source code and project files. One file I want to focus on is called Readme.html. So let's go ahead and take a look at the contents of Readme HTML. This file describes what the assignment is about. The objectives of this assignment, as described here, are for you to learn how to create, start, and join Java threads. There's a number of existing videos I've filmed earlier outlining the structure, functionality, and usage of Java threads, which you can take a look at here on my YouTube account. We'll, of course, cover this in class, but if you want to get a head start, I recommend you watch the videos to see what you're going to be doing. The assignment itself will use the threads that you create to make a working Android app called the PalantiriSimulator. And this app essentially contains a resource manager that restricts the number of beings from Middle Earth who can concurrently gaze into a fixed number of Palantiri. If you're not yet familiar with the work of J.R.R. Tolkien and Lord of the Rings and don't know what a Palantir is, you might want to take a look at this link, although you don't really have to understand it in any detail in order to be able to do the assignment. Let's now go ahead and take a look at how the assignment actually runs when we start it up in the Android emulator. This is what the program looks like when you run it in the Android emulator. If you go up here and click on the little ring icon, you'll get the menus option, and you can select the various types of being managers and Palantiri managers, which for the first program will be the Runnable thread being manager and the array blocking queue Palantiri manager, which you'll implement. You can change the number of beings by this slider. You can see now we have 10 beings, whereas initially we didn't have 10, we had 4. Likewise, you can change the number of Palantiri. As you can see, now we've got a lot more. We have 10. whereas before we only had 2. Let's go ahead and make that 2 again. And you can also go ahead and change the number of iterations, which is the number of times each of the beings will be looking at the Palantiri. If we come down here, you can see that you have various other menu options you can change. For example, you can change the transparency of the window. You can make it completely opaque versus completely transparent. You can change other things such as the performance, the animation, speed, percentages, and so on and so forth. A lot of these options are things that are mostly useful when you're trying to debug the program. So with that as background, let's go over here. We'll have 4 beings. We have some hobbits and a wizard. We have Gollum. We have man. And then we have 2 Palantir, or Palantiri, if that's the plural. When we click the Start button, you can see that a couple of the beings go ahead and start to gaze. You can see the states are indicated underneath the various icons. You can see we have little progress bars that keep track of how many times each being has gazed. You can also see it keeps track of the number of times each of the Palantiri has been gazed into. So we have gazing versus busy versus idle and so on. And then up here we have a little title bar that keeps track of information such as now they're all completed. And if everything goes according to plan, the results are all green when you're done. In contrast, if things fail, if you get an exception or your program doesn't work properly, then chances are the title bar will be red at the end. So that indicates that something's gone wrong. So that's just a quick summary of what the program looks like. I encourage you to play around with it, and it's really quite interesting. Shows off a lot of interesting user interface features, as well as the user interface design, which we probably won't talk a lot about in this class, but certainly worth understanding to have a deeper view of how to program Android apps. Now that we watched the program run in the emulator, let's continue on with our discussion of what's actually in the assignment, starting with an overview of the assignment structure and functionality. The PalantiriSimulator app is packaged as a project in Android Studio, and you need to use version 3.x, 3.1 or 3.0.1 and so on. The app internally is written both in Kotlin and in Java. The user interface is in Kotlin, and the framework and the part you'll be implementing is in Java. And the app itself demonstrates many fascinating Android capabilities. For the purposes of this particular assignment, however, you just need to focus on one directory, which is the Runnable threads directory, which is part of the Simulator Managers folder. And this contains the skeletons that you'll need to fill in. To compile the code, you'll need to use the provided Android Studio project. And of course, once you download the project from my GitHub account and you fill in the various to-do tasks and so on, then you'll go ahead and click the green Run App button in the Android Studio IDE. And that will automatically select the emulator to use. And I recommend you stick with versions 26 or 27, which are the more recent ones. You might be able to use the earlier versions, but I don't recommend it. Let's talk about what you actually have to do pragmatically to make things work. There's lots of folders and lots of files in the project, almost all of which you can ignore at this point. The Android program itself is structured in accordance with something called the Model View Presenter pattern. And the classes that are provided here are largely implemented for you. The relevant classes you'll have to implement are Runnable Threads Manager.java and SimpleBeingRunnable.java, and those are described down here. The places where you have to make the changes are indicated clearly with to-do comments, which show up in your Android Studio IDE with little blue colors on them, so it's easy to tell at a glance what you have to do. You'll make sure that you don't make any other changes to the code except to modify the to-do portions. If you start modifying other parts of the app, strange things will happen, and it will be very difficult for us to give you help because we won't know what you're doing. There are 4 to-do tasks in Runnable Threads Manager.java. They're summarized here, and I'll describe them in a second. And then there's a single to-do task in the SimpleBeingRunnable file. And we'll look at that also in just a second. Once you've got it all up and running, your app will be considered correct if all the beings can successfully complete all of their iterations, where you can set what the iterations count will be by the menu options we talked about earlier. A correct simulation should restrict the number of beings that are gazing to the number of Palantiri. So in other words, if there are 4 Palantiri, but say 8 beings, then only 4 beings should ever be able to gaze at a given time. And it's pretty easy to tell what's going on if you look at the visualization on the screen. And the visualization, as I showed you when we ran the app, has nice feedback to show the Palantir and being states, as well as the progress of the gazing iterations. So assuming everything goes well, as I mentioned earlier, the title bars will be green when you're finished, but if something goes wrong, then hopefully the title bars will be red. So you can tell at a glance something has happened and you need to go and do further investigations and debugging and so on. There's some additional work that the graduate students need to do. Students who are taking the class for graduate credit need to do some additional work in the Runnable threads manager.java file. And I'll talk about that when we do the detailed code walkthrough in just a moment. You can get all this code from my GitHub account. Once you've set up your GitLab account, make sure you use GitLab to store the code. It needs to be private in order to abide by the Vanderbilt Honor Code. And then, of course, you'll go through and fill in the to-do markers. This assignment is intentionally designed to be relatively simple. It's meant to give you some practice getting Android Studio up and running if you haven't worked with it before, give you a chance to learn a little bit about very fundamental Java concurrency mechanisms, basically the Java thread class. And it doesn't require you to use any of the sophisticated Java synchronization mechanisms, which we will cover later, or any of the more sophisticated Android concurrency or communication frameworks, which we'll also cover in future portions of the course. So at long last, we're ready to look at the actual skeleton code itself. I now have the skeletons that you've been provided open in my Android Studio IDE. You can see here we've got a directory called edu.vandy that has a pair of subfolders called app and simulator. The app is where all the interesting application UI code goes. This is all written in Kotlin. If you poke around here, you can learn all kinds of interesting things about Kotlin. And it's not for the faint of heart unless you know advanced Android UI programming in Kotlin, but it's very interesting. We might have a chance to go over some of that later in the class. The actual part you'll be implementing is written in Java, and it's in the simulator managers directory. And if you take a look here, there's 2 subdirectories, beings and Palantiri. We're going to focus on the beings subdirectory, in particular the runnable threads subdirectory under beings. And all the other stuff you see here that we're not looking at is all part of what I'll term the simulation framework. And that's what's providing all the magic to glue together your part of the code that you write with the threads with all the other stuff that gives the fancy animations and so on. So let's now go ahead and take a look at the 2 files that you'll have to fill in. Some parts of each of the files will be provided for you to give you the skeleton. Here's the first file called SimpleBeingRunnable. As the name suggests, this implements the Runnable interface, which is a Java interface that has a single method called run, and it's typically used as the target for a thread, which we'll talk about in class. So SimpleBeingRunnable implements Runnable and extends being. Being is one of these framework classes we'll talk about a little bit. It has a couple of methods provided for you. It has a constructor called SimpleBeingRunnable that takes a being manager as a parameter and calls up to a superclass to do some framework initialization. It's also got a run hook method, which of course is what it will get by implementing Runnable. And the run hook method will be called back when the thread is started. So when a being starts up, its run hook method gets called back automatically by the Java infrastructure. And that in turn will call the run gazing simulation method. And that's provided as part of the being class. And we don't have to know too much about how it works, except to know that run gazing simulation is a so-called template method with the template method pattern. And it takes a number of iterations it wants to run. And when it starts to do its thing, it's going to call back to a so-called hook method called acquire, palantir, and gaze. And this is one of the first methods you'll need to implement. And so as you can see, it has a to-do flag here, which shows up as a little blue symbol on the right-hand side of your Android Studio project window, so you know that you have to go ahead and fill this in. What you'll do here is you will call to a method in the being manager called acquire palantir, which will get a palantir. And this call will block if there are no palantiri available at the moment. It'll block until one becomes available. If something goes wrong, if for some reason you've got a buggy implementation, then a concurrency error may occur and that'll return a null. So in that case, you have to go ahead and call the being.error method, which will throw an exception and shut things down cleanly. Let's assume for sake of argument we don't have that problem, so we get back a Palantir. Then your code will gaze at the Palantir for this being. So you'll have to take a look at the Palantir interface, which is defined over here, right there, the Palantir interface. And so there's a method called gaze, and so you'll gaze at this method, and that will then block it for some random period of time that you can, in some sense, control through the parameters you've given the menus that you have available through the menu option in the application we looked at. Finally, after the gazing period is done, then you're responsible for releasing the Palantir for this being and giving it back to the Palantiri manager via the being manager. And I won't go into details of why it's designed that way, but that's the way it works. So you'll take a look at being manager, you'll see there's a method called release Palantir, and you'll have to call that with the appropriate arguments. Make sure that that method always gets called even if an exception happens to be thrown. And so that suggests you'll need to use a try finally block inside of the code that you write here. Okay, so that's SimpleBeingRunnable. Let's now go take a look at Runnable Threads Manager. And as you can see, this has got a bit more going on. You have to implement a few more methods, but it's still fairly straightforward. This Runnable Threads Manager is a being manager, so it extends being manager, and it's used to manually create a pool of Java threads to run the being simulations. And if you were to take a look at the being manager class, you'd see it's a generic class that's parameterized by the type of being, which in this case is our SimpleBeingRunnable class we just looked at. Let's take a look down here at one of the methods. This is a method called newBeing, and this is probably the easiest method you can fill in to start with. This is a factory method that's called by the framework in order to return a new SimpleBeingRunnable. So it's used when the framework is creating the appropriate number of beings based on the menu options. And so you simply have to write the code that figures out how to make a new SimpleBeingRunnable. And that shouldn't be too hard to figure out because the constructor is right there. Let's now take a look at one of the fields, really the main important field that's part of the Runnable Threads Manager. This field is called mBeingThreads, and it's a list of threads that are used to keep track of which of the beings are going to be created and run in order to acquire the Palantiri and gaze. So it's basically a collection that keeps track of beings which are implemented as threads. We'll talk about how this list is initialized in a second. Before we do that, though, there's a entry point method called runSimulation. And this is the method called back by the framework when the program begins to run. And what it'll do is it'll go ahead and create all the various resources and start them and do all the work if you implement it properly. So here's what you need to do. You'll need to first call a method to create and start a thread for each of the beings. You'll then need to call a method to start a thread to wait for all the being threads to finish, which were created in the previous call. And then the third thing you'll need to do is you'll need to take the result of the second method call, which is a thread, and you'll need to block on this thread until it's finished. And so you'll need to use a method we'll talk about called join, which is a method that's used as a barrier synchronizer on the completion of a thread. When the thread finishes, join will return. Well, lo and behold, the two methods you have first are both things you have to implement in this class. So the first one is called beginBeingThreads, and that's of course the one you'll call here. And the second one is called waitForBeingThreads, and that's the one that you'll call here. Let's take a look at beginBeingThreads first. Some of this code everybody has to implement. Other parts of the code only the graduate students have to implement. The graduate students or people taking the class for graduate credit always have a little extra work to do in the assignments and the quizzes and the final and so on. So everybody has to call the getBeings method, the factory method, on the being manager in order to get back a list of beings that are then iterated through. And for each being in the list, we need to create a new thread object for each of these beings. And then we'll add this to the list of mBeingThreads. Now, there's several ways to do this. One way to do it is to use a Java 7 for each loop. That's very simple. Another way to do it, which is what I prefer, is to use Java 8 streams. So you can iterate through Java 8 streams, and you can use map and peek and collect and so on in order to be able to do the same thing. You're free to do it either way that makes the most sense, although I strongly encourage you, if possible, to use the Java 8 mechanisms because they're more powerful. The graduate students also have one extra step. They have to set an uncaught exception handler for each being thread. And what happens here is if for some reason an exception occurs and the thread doesn't know how to handle it, this uncaught exception handler will be invoked, and what we want it to do is call back on the being manager error method to indicate that an unexpected exception occurred for a given thread. Undergrads don't have to do this, although you're free to do it if you want. You'll get a little better error messages if your program gets really crazy. After you create the mbeing threads list, then you go ahead and iterate through it through whatever means makes most sense to you and start all the threads in the list of threads. So that's the next piece of the puzzle you'll have to implement. So that's, of course, the code that'll get called up here. Down here is the next method. This is the wait for being threads method. And what this is doing is this is going to start one thread, which will then be used to wait for all the other being threads to finish. And this method will return the thread, the waiter thread, back to the caller. And of course, that will then be used to join with the results when everything else is finished. So this is a very simple form of what's called barrier synchronization. Here's how the method should be implemented. What you'll need to do is create a Java thread that will be used to wait for all the being threads to finish gazing. If for some reason an interrupt occurs or an exception occurs, then the being manager error helper method is going to need to be called back, and you'll have to figure out how to do that properly within the thread, the waiter thread that you create. After you create this waiter thread, you'll then go ahead and start the waiter thread, and then you'll return the waiter thread back to the caller. And then that will be used up here in the run simulation method in order to block until everybody's done. So we're using a waiter thread to essentially wait for all the other gazing threads, the being gazing threads, to finish their work. Well, that's basically it. That's the summary of what you'll have to implement. Again, relatively straightforward. If you are familiar with threads, this should take you very little time to do. Believe me, we will do a lot more interesting things as the progress of the semester goes forward. We're going to do lots of other stuff with this program. We'll be doing some interesting things with Palantiri managers. Right now, the Palantiri manager that we have for this assignment, which I've given you as an implementation, does a very simple-minded way of giving access to the resources that are the Palantiri, or the set of Palantirs. And the way it works is it uses something called an array blocking queue. This is intentionally very simple and inefficient since it's really not meant for anything other than just getting things started. I'll walk through it really quickly because eventually you'll have to figure out how to implement this when we get to assignment 1B. So what basically we have here is something called an array blocking queue manager, which extends Palantiri manager. That's the thing that's going to be mediating access to these limited resources from concurrent threads. As you can see here, we have an array blocking queue, which is a data structure that's part of Java that is used to allow a certain number of objects to be accessed, but will not allow a thread to progress if there's nothing in the queue. And we'll see how that gets used in a second. So here we have the array blocking queue of Palantir, which is called available Palantiri. There's a couple of methods we give you. We give you reset, we give you build model. And what build model does is it gets the count of Palantir objects or Palantiri, which is what was given in the menu selection in the app. It then goes ahead and makes an array blocking queue of that many Palantiri. And then we go ahead and we iterate through each of these Palantiri and we stick each one of them into the available Palantiri array blocking queue. So now we've got a queue with n Palantiri, where n is the number of Palantiri we have. Here's what acquire looks like with this implementation. As I mentioned, it's ridiculously easy. All it does is it says available Palantiri.take, and that will acquire a Palantir, blocking until one is available. If there's not one there already, then it will wait until one becomes available. We'll see how it gets available in a second. If there is already one there, it'll just go ahead and return it, whatever one it happens to be. So the nice part here is that blocking happens automatically if we reach the limit of the number of available Palantiri. So very simple code. It's not very efficient. We can do much better, as we will later, but basically that's how it works. Here's what release does. Release takes a Palantir and it goes ahead and it sticks it back into the array blocking queue. It goes and puts it at the back of the queue after doing a little sanity check to make sure that the Palantir isn't null. So very, very simple. We also have another method called available permits, which gives back the number of Palantiri that are currently available for use, and that's simply the current size of the array blocking queue. So as I mentioned before, the second assignment, or subsequent assignments, including the second half of this assignment, so assignment 1B, will have you implement a much more interesting way of doing the Palantiri manager. Right now, this is a simple one just to get it up and running without you having to think much about this. And so when we finally get to, say, week 2 or maybe week 3 of the course, we'll cover how to do this part, and then we'll be changing this as we go through the rest of the course. So that's an overview of all the various pieces. You don't have to worry about the implementation of the Palantiri or the Palantiri manager at this point. Only focus on what's over here in the Runnable Threads folder and the Runnable Threads manager and the SimpleBeingRunnable class. Now that we've looked at the source code that provides the skeletons that are part of the project, let's take a look at the tests. I'll show you how to run the tests, and I'll also briefly describe what they do. One of the tests contains a set of JUnit tests that exercise many of the PalantiriSimulator features. You can use this test to determine that the functionality that you implement for the assignment is correct. There's another test package which contains Android Studio instrumentation tests. And these are used to provide a stress test that runs your app automatically, so you don't have to sit there and manually run it. Both of these tests are important, and you should make sure that your solutions always pass these tests before you push them and submit your initial and final submissions for the assignment solution. I'll start by showing you the unit tests. These are under the App, Java, EDU, Vandy Simulator test folder. If you go in this folder, you can see there's a number of different test programs in here that exercise the BeingRunnable tests and the Runnable Threads Manager. And so all you have to do here is go ahead and essentially right-click and click on Run Tests in Simulator. And that will go ahead and start. It should begin by building the Gradle file. Might take a few minutes to go ahead and do the compiling and so on. And then it'll go ahead and begin to run the tests. As you can see, if everything goes well, as it did in this case, all the tests that run will be green. If something goes wrong, then the tests will be either red or yellow. When you run your, before you submit your initial submission, before you submit your final submission, you should always make sure that all the tests that are the unit tests run correctly. Now that we've run the unit tests, I'll go ahead and show you how to run the instrumentation tests, which basically provide a stress test for the app that's automated. So you'll click on the App, Java, EDU, Vandy, App, Android test folder. And once again, you right-click on that. And this will prompt you to start up an emulator. I'm going to run AI 28 version. And you can see what happens is that my screen pops up here. And if you look carefully at this thing, you can see that it's going to go ahead and start launching the program automatically. It's got a bunch of diagnostics here on the right-hand side. And you can see that this particular test is going to have 10 beings and 6 Palantiri. And it's going to do 10 iterations. And it also does things like rotate the screen in order to see what that does. And by the time we're all done, if everything goes according to plan, it should have completed all the iterations, and everything should be green. You'll notice that the title bar at the top is green. So this is a good way to kind of stress test everything. When it's all done, it tears everything down, and this was a successful run. If something goes wrong, then you'd end up getting essentially a red labels in the title bar, and then you'd have to go back and see what had happened. My recommendation in that case would be to make sure that you carefully run the unit tests and look and see if there's any problems there as well. So that essentially shows how to run the instrumentation tests, which stress test your app. And at this point, you should be good to go.